Thanks everyone for joining. So we're going to look at a couple of different things to consider, as threats to business continuity, as it relates to storing your data and just in disaster recovery and business continuity in general. We're going to kind of unpack three different things in today's session. First, thinking about physical server failure, something that's been a concern for decades, and how to respond to that, how to plan for that. And then another thing we're going to look at is logical data corruption, which doesn't get as much thought, but this is the case where someone actually accidentally runs a query, that might damage some data, accidentally drop a table, maybe an integration goes nuts and accidentally, just corrupts a bunch of your data. Nothing's technically broken, but your data is bad now, and you got a problem you got to recover from. And then the third we're going to look at is malware, ransomware, some kind of a bad actor, like deliberately, damaging, encrypting your data, and maybe holding it for ransom, and how you recover from a scenario like that. So the first one I'm going to talk about is, what do we do about physical server failure? And this one I feel like has an easy answer these days, which is, virtualize everything. There is a very small performance impact these days with virtualization that doesn't really justify staying with, running workloads on physical servers unless they're super, super portable, in my opinion, just because the virtualization, you have the elastic storage capacity, and if the app gets bigger, you need a bigger hard drive. It's no problem. You just expand the disk. Same thing with CPU and memory, and you've got portability. You can run that virtual machine on any server. You can migrate on-prem, and you can move it to the cloud if you want. It's just super portable, and there's lots of tools to migrate, between different hypervisors out there. And then there's two different things to think about from that you can do with virtualization. One is a failover cluster, and that is a business continuity tool that allows you to run a virtual machine on more than one server. We're not going to unpack that super detailed today because that's really a topic unto itself. But it is a tool that's out there, but most people who are already using it, have extensive experience with it. It's a specialization. But there is another one too, Hyper-V Replica, which is, I think, a good fit for smaller organizations. It's a different type of tool because with Replica, you've got a copy of your virtual machine running on another server, and they don't require any dedicated infrastructure like the failover cluster does. They can be just, another server on the LAN, essentially, connected over the network, and you have a copy that's only a couple minutes old or even a couple seconds old. So this is a great tool for disaster recovery if that primary host goes down. In Azure, both of these are baked in. If you're moving workloads over to Azure, you've got availability groups where you can have two virtual machines, and you can do things like, cycle your updates, so you can keep your application online. And they handle the, the clustering for you on the back end. They've got, your machine in a region with multiple servers capable of hosting that virtual machine. So the next area is logical data corruption, and this one in particular, I wanted to talk about this in the context of databases, and why it's important to have SQL full recovery model and transaction log backups. So some of you might be familiar with full backup versus log backup. So a quick refresher is that full backup is exactly what you think. It pulls the entire database into a backup file. But the log backup is different. The log backup is done when your database is in full recovery mode. And in that mode, every single change to the database gets written to the transaction log and isn't purged until that log is backed up. So it's like a ticker tape of all the accounting transactions that have happened to the database. So the nice thing about a log backup when you're using full recovery mode is that you can restore your database to any specific point in time that you want, not just when you took a log backup, say these are every 4 hours here, but any time in between them. So for example here, we have got a full backup taken, say at night, and then we have our first morning log backup, and then maybe our late morning log backup, and then right around noon, a data corruption event occurs. So what we would do to recover from this event is actually take another log backup after the corruption event occurred so that we have this little bit of transaction data backed up then. And then we can do a log restore and say we want to restore these 2 logs and a fraction of this log backup, and we want to be like 1 minute before the data corruption took place. And this way we can get just exactly right up to the point of failure, which is a great feature of SQL that not a lot of people take advantage of. Most organizations, leave their databases in simple mode, in the SMB space, but full recovery mode is included as a feature even of the free version of SQL, and it's really it's a great tool to take a look at. And then the third area is like malware and ransomware. In this case, we've seen and been brought into scenarios where a client's been completely compromised, their data's been encrypted, their backups have been encrypted, and it's being held for ransom. Not fun at all, and really, it's important to plan for that scenario. We're going to do all the OPSEC in the world, and it's important to do, but we also need to start with a plan saying, say all of our efforts have failed and we've been compromised. Do we have a plan for that scenario? We're going to talk about what to do in that case, and maybe in one potential solution to that problem using Azure Recovery Services Vault. The traditional computing models, when I say that, I'm talking about like files on file shares, on the local network maybe, or working out of databases that are on-prem, and that type of thing. That traditional model where we're working with files, especially on servers, is kind of vulnerable because that's exactly what these malware applications are looking for. They want to encrypt the files on your local machine and encrypt the files on your network, hoping that you don't have backups. And then they want to, if they can, try and find those backups and encrypt those as well. So we're going to look at an alternative, considering storing data in the cloud in some platforms that provide a little bit more resilience against malware. So the most important thing about your backup is it needs to be separated from your production data, and that is kind of one of the tenets anyway of ensuring your backup security. If we were to assume that someone compromised the environment, had the ability to encrypt the data, if the backups are on that same server or even on that same network, they're at risk too. Maybe we're following best practices and we've got backups off host, but if the attacker is able to access the network, they might be able to do like an escalation of privilege attack or something like this, and gain administrative control of the whole network and start looking around at the other servers, finding SQL backup files to go ahead and encrypt those too. So it is important to keep those backups as isolated as possible, so that isn't something that can happen. And so, one way to do that is to have them on, a completely different network. Virtualization really helps with this. So if somebody compromises the VM, they don't necessarily have access to, to the backup, or necessarily the rest of the network if that backup process is, is external to that, to your domain. But then also when it comes to backups, when you want to build a solution that has mechanisms in place to ensure that any kind of delete operations are authenticated, that needs to be protected by ideally like a 2-factor authentication or something like that, so that just because you may have compromised credentials, someone can't get in there and delete your backup. And then is there an alert mechanism in place? If one of your backups, somebody issues like an alert or a delete command, are you going to get a notification? So we're going to think about securing backups, from in the context of Azure, and how Azure Recovery Services Vault and Azure Backup would work for that. So we need a secured multi-layer platform for that, and Azure Recovery Services Vault provides that by having a backup solution that's completely separate and external to the VM. So they're off-site from your virtual machine and backed up through the Azure Recovery Service framework, where it's replicated to multiple Azure data centers. And that way, like a delete operation, can't completely remove those files for you. And then also there's multi-factor authentication, which is baked into the Azure Active Directory. So logging in and making changes to your Azure Recovery Services Vault, you would need not only a valid global admin for your Azure Active Directory, but also you would need access to that physical device that's got your two-factor on it. So that might be your phone. And then the backups are encrypted at rest, so it makes it more secure to have your data that's at rest sitting on the servers there. No one has access to that except for you. And then there's monitoring notification built in as well, so that if there's a backup failure or a delete operation or something like that is issued, you're going to be notified of that. And then I think maybe one of the most important and valuable features of the Azure Recovery Services Vault is the delayed delete. So, when they built this vault, they kind of built it with, ransomware in mind. And so when any kind of destructive command is issued, like delete these backups, there's actually a 14-day hold put on that command in Azure, so that you're basically in a holding pattern there, and it prevents this scenario where like an attacker is attempting to destroy your backup, so you have to pay the ransom. So the other thing is is workflow. And thinking about workflow is something that can also reduce your organization's risk and exposure towards malware, in particular. Using tools like OneDrive and SharePoint Online, users have file versioning baked in. So the fact that it's easy to roll back to a previous version of file makes this kind of platform far less attractive to to malware authors, because it's trivial. If if they encrypt your files, you can just roll back the whole SharePoint site to a previous version, and even if every single file has been encrypted, you just get them all back. So we see it's very rare that that's even an issue, because it's just there are far more attractive targets that these malware authors are targeting. The other one is we talked several times about multi-factor authentication, and that is just a really great way to conveniently protect logins. And Microsoft is really moving away from the idea of a username and a password, because it's inherently insecure. Anybody with the username and a password now suddenly has full keys to the kingdom. Whereas with two-factor authentication, where now you've got you've proven that you own a physical device that's part of your credential, and we're seeing a move towards that sort of device authentication and away from passwords. We're going to see more of that with like Windows Hello, basically allowing you to Azure AD join a machine natively, and you just have a PIN code you type in on the machine instead of instead of password. And then that also introduces some nice features like Intune Mobile Device Manager, so you can push policy down to machines that are connected to the internet, but not necessarily your on-prem domain. Which is a problem for remote users. A lot of times you're trying to push policy to those machines, but they never connect to the network. Intune and Azure AD provide a good solution for that. So another thing you can do is, obviously, a lot of these attacks come in through email, phishing attacks, spear phishing, and using Exchange Online protection, which is included with all Office 365 subscriptions, is a good way to mitigate that. There's a lot of other good MX filtering engines out there too. So you just definitely want to make sure you've got some kind of intelligent filtering happening in your email. Another one that is on top of Exchange Online Protection is called ATP Advanced Threat Protection. That's a service of Microsoft 365, which is basically Office 365 with the Enterprise Mobility Suite and a Windows 10 license bundled in. And that gives you some extra features like the ability to they've got an AI engine that protects spoofing attacks and spear phishing attacks, where a message appears to come from someone within your organization with some kind of call to action, like, hey, I need gift cards or a wire transfer right now. They've also got a like a sandboxing engine that unpacks and executes all of your file attachments to see if they have any suspicious behavior, which is kind of cool. So it's kind of next level file attachment filtering. It does a lot of neat stuff. So then I wanted to go through an actual demo and show you guys how the Recovery Services Vault works. Take a look at backup policy and show you the granular file recovery features that are available. And the neat thing about the Recovery Services Vault, you'll see is, those snapshots of the virtual machine hard disks are out there, and we just can attach to them. We don't have to actually wait for them to restore. I'll show you. There's basically an attach process. So if we decide that we need to restore data from an earlier snapshot, it's a very quick process to get the data back into the VM, and this all can be done while the virtual machine is running, so your production database can continue to run as, and do transactions if you wanted to maybe just grab some specific rows or validate data out of a previous version of the database. So we're going to take a look at that. So this is an Azure virtual machine that we're in right now, and I've got the portal right up here, and I'm going to take a look at the Recovery Services Vault right here. And inside this vault, we can determine like the backup policy for the different assets. So like, for example, if I look at the default policy here, I can determine what type of snapshot recovery points I want. So they use a rotation, so I can say that I want to keep 30 days of daily backups, and then weeklies for a year, and then maybe monthlies for 5 years. So that way I've got, without using as much storage, I can get back out quite a long time. And then, so this machine here, you'll see we've got a boot drive. All Azure VMs come with this temporary storage. This is ephemeral storage. It'll go away every time the machine is reloaded, but it's good for temp data and your swap and stuff. We don't actually use it for actually storing any data though. And so this E volume here, this is the data volume that's got our data on it. And so we want to restore an E volume from a week ago, for example. That's what we're going to take a look at. So I'll go down to the backup tab. Here are the backup items, and pull up one of our VMs. So here's our SQL and our demo environment. And then you can see I've got all of the different backups that are available. And application consistent means that the SQL database was backed up in a consistent state, so there were no transactions that were in the middle of posting. So that's important, obviously. Any kind of backup needs to be application consistent. And then so right over here, we can do like either restore the entire VM back to this point if it's using managed disks, which is really nice. So then anything that happened to that VM just, didn't happen ever. It just rolls back to, this snapshot point. Or I can do file recovery, which is what I'm going to show you guys today. And the way this works is we download an executable, which is kind of like only used, one time. This is kind of generated on the fly. And then there's also a passcode that they're going to provide to us that we'll use to attach to that Recovery Services Vault backup point. And that's where we play the Jeopardy music. So here is the file recovery PowerShell that it runs, and then we've got this one-time passcode that we enter in there. And then what it's going to do is connect to those volumes over iSCSI, and we'll see them appear right here on the server momentarily. And then if we want to, we can copy files from that location. Often what we do is just attach the databases that are on this new G drive here that just appeared. We'll have databases right in here that we can just attach directly in SQL, and then run queries between the two databases. So it's just like this drive has just been plugged in to the host. I got my old E drive here, which is now G, from the previous snapshots. Now they're both running, and now after a period of time, this will be automatically disconnected from the server. I believe it's 24 hours, but you can keep it connected longer, or you can disconnect it as well. But it's that simple. Now if we wanted to attach, we could just attach to the G drive believe that was actually G is our new E drive, and I've got my, my databases right here. So if I wanted like my Dynamics database, I could just specify like an attach as name here, like old, and just reattach that database directly right from there. And that's it. We can pull our data out of here as needed. All right, so thank you everyone for joining. Pull up our rest of our presentation here. So now that we've done our demo, and if anyone has any further questions, we can open up for questions at this point. We've also got our blog there. We've got further reading there as far as securing Office 365 and securing Azure environments and backup and recovery. There's several articles available.
Thanks for watching. To learn more about our products, visit www.crestwood.com. Hope to see you there soon.